Welcome students, welcome to this industrial fluid power session. This session we are going to see about the introduction to oil hydraulic system. So under this session we are going to see about the practical applications of hydraulic system, general layout of oil hydraulic system, merits and limitations of oil hydraulic systems. So let us see what is a hydraulic system. A hydraulic system is a drive technology where a fluid is used to move the energy from an electric motor to an actuator such as a hydraulic cylinder. The fluid is theoretically uncompressible and the fluid path can be flexible in the same way as an electric cable. So what is a hydraulic system used for? The hydraulic system are mainly used where a high power density is needed or load requirements change rapidly. This is especially the case in all kinds of mobile equipment such as excavators and in industrial systems such as presses. In wind turbines, hydraulics is used for pitch and brake control. In some cases, different auxiliary systems such as hatches and cranes are also powered by hydraulic systems. Why are hydraulic systems used? The main reasons for using hydraulic system is the high power density and secondly, the simplicity coming from using few components to realize complex and fast moving machines with a high degree of safety. Fluid power. Let's see the fluid power. What do you mean by fluid power? So fluid power is the technology that deals with the generation, control and transmission of forces and movement of mechanical element or system with the use of pressurized fluids in a confined system. Let us consider this image. We are giving the using this hydraulic as a medium. We are giving the force this side. We can lift this. If you're giving the less force, you can with the less force itself you can lift the very heavy weight. Okay, this is the example of a hydraulic system. So fluid power definition. So it is the use of a confined fluid flowing under pressure to transmit power from one location to another. Okay, two of the most important advantages of fluid power transmission are its ability to multiply force and its flexibility to change the direction quickly without damage to the system. So this is the basic components of a hydraulic system. Okay, it's having an oil tank or reservoir. It's a filter from the oil tank. The oil goes to the filter and using pump, it pumps. The pump is run with the external motor and then goes to the pressure regulator. It regulates the pressure. This is a direction control valve. Whether you need a forward motion or reverse motion, this is the actuator. This actuator is connected to the load in whatever the application it may be. So this is actuator. This hydraulic actuator is a device used to convert the fluid power into mechanical power to do useful work. So this actuator may be of linear type, example hydraulic cylinders, or rotary type, example hydraulic motor, to provide linear or rotary motion respectively. So this is the hydraulic pump. This is the hydraulic pump is used to force the fluid from reservoir. Used to force the fluid from the reservoir to rest of the hydraulic circuit by converting mechanical energy into hydraulic energy. So pump is converting the mechanical energy into hydraulic energy by pressurizing the fluid. Then these are the valves. So the valves are used to control the direction and some of the valves are used to control the pressure and flow rate of a fluid flowing through the circuit. And this is the external power supply, that is motor is required to drive the pump. And this is the reservoir or oil tank is used to hold the hydraulic liquid, usually hydraulic oil. And this is the filter, and filters are used to remove any foreign particles so as keep the fluid system clean and efficient as well as avoid damage to the actuator and valves. And piping system, this piping system carries a hydraulic oil from one place to another. And this is the pressure regulator which regulates or that is maintains the required level of pressure in the hydraulic fluid. Hydraulic applications in industrial, we see the hydraulic applications in industrial. So electrohydraulics is the mechanism used for controlling the industrial applications of hydraulics. Precise and fast response is an advantage of this. Plastic, plastic processing machinery steel making and primary metal extraction applications, automated production lines, machine tool industry, paper industries, loaders, crushers, presses, textile industry machinery, etc. are some of the examples of industrial hydraulics. So this is how the industrial presses looks like, hydraulic presses looks like. And mobile hydraulics. So in mobile hydraulics, the hydraulic system is controlled manually. Building and construction equipments like cranes, excavators, backhoe, earth moving equipment, etc. Tractors, irrigation system, material handling equipment, tunnel boring equipment, rail equipment, etc. are some examples of mobile hydraulics. Okay, this is the cranes and this is the backhoe and this is the tractors and trucks. They're using hydraulics for lifting the trucks and automobiles. Hydraulics have many interesting applications in the automobile industry. Most of the important work using the principle of hydraulics, power steering, shock absorbers, windshields, and brake are the common applications of hydraulics in vehicles. Two post lifts and four post lifts are used in hydraulic industry to lift vehicles for servicing and inspecting. So we are using hydraulic power steering. Here this hydraulic system is using, and this is hydraulic shock absorbers we are using, and hydraulic brake system, two post lift and a four post lift. These are used in a servicing and inspection. And now let's come to the material handling equipment. So in any mass production factory, use of material handling equipments is unavoidable. Hydraulic pallet truck, hydraulic lift table are some of the examples. All material handling lifters, pickers, stackers use hydraulic power. So this is the hydraulic lift example. This is a scissor cut hydraulic lift, and this is a hydraulic pallet truck, and this is a hydraulic lift truck. And in marine applications, hydraulic plays an important role in maintaining the stability and control of ships. Steering gears, bow and stern thrusters, engine room maintenance systems, including pumps and jacks, deck machineries like cranes, winches, hatch covers, mooring drums, and others are examples of hydraulics in the marine industry. Okay, so here these cranes are used in the marine and in harbor. They are all used in with the application with the help of hydraulic system only. And in aerospace applications, airplane, rockets, spaceships, etc. use hydraulic system for various applications. Aerospace industries use hydraulics for adjusting wings, retraction and extension of landing gears, opening or closing of doors, brakes, steering, etc. Okay, this is the landing gear applications, and here they are using the hydraulics in the adjusting the wings. Now let's see the comes to the application in mining. Hydraulic fracturing is one of the advanced mining technology used for extracting unused gases or oil beneath the earth's surface. In this approach, a high pressure mixture of water, sand and other chemical additives are passed into the cracks. Okay, this is a hydraulic fracture systems. So this is how hydraulics in mining they're using. There's making initially they're making a one drill. After that they're sending the water or hydraulic oil. That hydraulic water will mix it with the gases inside the cracks or inside the under the earth. They on the other side they will take the water so that the gas also will comes out. So now let's see how the hydraulic applications or how this hydraulic came into existence in this much application in this video.
Over the brink of Niagara Falls, 1,000,000 tons of water pour, and 212 feet below, the mighty torrent falls against the blades of huge turbines, creating horsepower to light 275 cities, towns, and villages, and run the motors of thousands of factories. This ability of liquids to transmit power comes from one important natural law. You can't push a liquid together or compress it into a smaller space than it already occupies. If you take a piece of ordinary pipe and fill it with liquid and put a plunger at both ends, any blow on one plunger sends the other plunger flying out. Liquids can't be compressed, so here's what happens inside. The power of your blow is transferred to the other plunger by hydraulic transfer of power. This is the simplest kind of hydraulic system. Bending the pipe doesn't affect this transfer of power at all. It goes around corners just the same. When one plunger is pushed down an inch, the other end comes up an inch, and a pound of pressure exerted at one end is transmitted to the other. Suppose we have 4 pistons at one end and only 1 at the other. Now, when the single piston travels 4 inches, each of the 4 at the other end travels 1 inch. A large piston of the same area behaves the same as 4 smaller pistons. Moving the small piston down 4 inches carries the large piston up only 1 inch, but with 4 times the force applied. This is the principle on which commercial and industrial hydraulic systems are based. Down in Dixie, billions of pounds of cotton are baled up every year by the power of hydraulic presses. With Uncle Sam's long-range guns, not only are power and reliability needed, but minute precision is required. Precision that aims these mammoth guns within limits of 1/1000th of an inch hydraulically. The hydraulic stage works by the same method and times its cue right on the nose with the reliability of an old-time actor. This model is a hydraulic system which shows how the hydraulic press multiplies power. This is the pump. This tube holds the liquid through which the power is transmitted, and these 4 cylinders at the other end receive the power. The movement of the large piston compresses or crushes anything put in the press. The hydraulic stage operates with the same reliable elements. The accurate hydraulic transmission screw in the coast defense guns is more complicated, but in principle, it is the same as the lift and the press. In any hydraulic system, regardless of how many cylinders are attached to a master cylinder, each of the small cylinders receives the same amount of pressure and moves the same distance as the others. This principle is used in the latest application of hydraulic transfer of power, stopping the modern motor car. The master cylinder is placed under the brake pedal, and a power cylinder is put in the brake of each wheel. Now, when you press down on the brake pedal, each of the 4 power pistons is forced an equal distance against the brake shoes, pressing them uniformly against the brake drum. The shoes are hinged in such a way that the entire lining contacts the drum throughout the life of the car. No grab at the top or bottom. Smooth, even, taking hold by the entire shoe surface. These are the brake shoes of a new car. Let's paint this pair black and examine the wear they take. Note the even grip on the shoes in the first 20 miles. Perfect contact at 5,000 miles. And after 20,000 miles, uniform wear and still good for many more. For durability, the linings must be hard, uniform, and unaffected by moisture. All else being equal, long life and effectiveness of the brake depend on the amount of material contacting the drum. Brake drums must be wide and large in diameter, smoothly machined on the inside. A car that takes 90 horsepower to go from a dead start to 60 miles per hour in 20 seconds can stop in 4 seconds, but it takes 450 horsepower in the brakes. The final safety and control of the car depends on the construction of the brake itself. It is the brake itself that stops the car, not the hydraulic control. Perfected hydraulic control transmits the power from the foot pedal to the brake itself and gives you the sure, quick stopping safety of the modern automobile.
Now let's see the advantages of hydraulic systems. So large load capacity with almost high accuracy and precision. So smooth movement because of very less frictional resistance. Automatic lubricating provision to reduce to wear. Division and distribution of hydraulic force are easily performed. Limiting and balancing of hydraulic forces are easily performed. Use of flexible connections in hydraulic systems permits generation of compound motion without gears and complicated mechanical drives. The noise and vibration level produced by hydraulic pump is very low. So let's see the disadvantages of hydraulic system. A hydraulic elements need to be machined to a high degree of precision. So leakage of hydraulic oil poses a problem to hydraulic operators. Special treatment is needed to protect them from rust, corrosion, dirt, etc. Hydraulic oil may pose problems if it disintegrates due to aging and chemical deterioration. Hydraulic oils are messy and almost highly flammable. Now let's see about the important properties of hydraulic fluids. First one is the compressibility. The liquids are incompressible in nature, hence they are suitable for precise motion control. Hydraulic oil should have low compressibility for better performance. And viscosity. Oils with low viscosity flow easily, but thick oil flow with some difficulty and result in pressure loss in the pipes and fittings. The low viscosity oil do not lubricate very well, hence the right balance between pressure loss and lubricity is required while selecting oil viscosity. Demulsibility. The ability of oil to resist with mixing with water is known as demulsibility. So low foaming tendency. A good hydraulic fluid will not absorb air easily and will release it quickly without causing foam. Oxidation. Oxidation causes the oil to thicken and produces varnishes which strain the component surface. It reduces life of oil. Chemicals may be added to improve oxidation of oil. Good heat dissipation. The oil should carry out the heat generated and dissipate to the atmosphere easily and at faster rate. Wear resistant or good lubricity. Chemicals are added to improve wear resistance of oil for reduction of wear during contact with moving components. Corrosion resistance. The oil should have high corrosion resistance to eliminate the problems related to corrosion. 4 points. It is important during low temperature applications in cold climates. The oil should have low pour point temperature. Flash point. It is the temperature at which vapor of oil give off when in contact with flame. It is required for high temperature application. Non-toxic, easy to handle and easily available. Hydraulic oil should be non-toxic for safe use and handling. It should be easily available at economic price. Now let's consider the hydraulic fluids. There are three types of fluids: petroleum-based hydraulic oils and water-based hydraulic fluids, synthetic hydraulic fluids. Petroleum-based hydraulic oils. These are thick oils similar to engine oils used in automobiles. These are most popular and used in major hydraulic circuits. Special additives are added to these oils so that its foaming tendency reduces, its lubrication properly improves and becomes user friendly. What are the advantages of petroleum based hydraulic oils? It's having a good lubricating property, rust preventive, heat dissipation tendency, and easy to keep clean. And the disadvantages are these oils have tendency to ignite. So in hazardous places, these oils are having least choice. These oils make the ground surface slippery, which is due to leakages. So the slippery ground can result into accidents. Water-based hydraulic fluids. These fluids are water-based, that is, water is based in which other liquids are mixed. And are three types: water in oil emulsion, that is water 60% and oil 40%; oil in water emulsion, that is mixture of oil in water, water plus glycol, water and polyglycols are mixed in 50%. Then comes the synthetic hydraulic fluids. These are non-flammable. It can be used at high temperatures up to 150 degrees Celsius. These fluids cannot work at low temperatures. These are most expensive fluids and rarely used. Thank you students. Thank you for watching this video. Let's see in the next class.